If you start from kinematics of constant acceleration, one of the formulas is v squared equals v0 squared plus 2a delta x. If you multiply that equation by 1/2 m, you get 1/2 mv squared equals 1/2 mv0 squared plus ma times delta x. 1/2 mv squared is what we call the kinetic energy. 1/2 mv0 squared is the starting kinetic energy. Ma is the sum of the forces, or the net force. So the change in kinetic energy, if you subtract that over, the change is equal to the net force times delta x. Now, that net force means the sum of all the forces. Well, some forces are what we call conservative, and we can write what's called a potential energy function for them. So gravity is conservative, the force is mg, and the potential energy is mgh. So kinetic energy initial plus the net work done by all forces is kinetic energy final. If we split the work into work done by conservative forces and work done by non-conservative forces, the conservative forces we can replace with u0 minus u final. Initial minus final. I know that's backwards from final minus initial. That's the negative of the change. As a result, if we bring that over, we find the conservation of energy, k0 plus u0 plus any work done by non-conservative forces is k final plus u final. Just plain k plus u. Ultimately, all the forces in the universe are conservative as far as we know. It's just that some practical ones, like friction, we can't really track, and that's what the non-conservative work term is for. So if you have, say, a frictionless situation, you might be able to ignore that term and get the usual statement of conservation of energy. Kinetic plus potential equals kinetic plus potential. You have a conserved quantity. If kinetic energy goes up, then the potential energy had to go down because the total's the same.